And we are live, I hope. So, welcome everyone to the Gren 2024 winter release, or the tour of the 2024 winter release. My name is Robin Hansen. I'm the lead developer of the Gren programming language. And today we're going to talk a little bit about the release that's being announced on Monday, but which is actually available right now. So the plan for this stream is to first talk a little bit about the significant developments since the 2024 summer release, or 24S as we call it. There's been a lot of things that's happened outside of the project, of the code itself. Um, and then we're going to jump right into what is new in this 24 winter release. We're going to have a demo showing off some of the things. And finally, we're going to talk about the plan for the next release, the 2025 summer release. We can talk a little bit about how you can contribute to the Gren project should you want to. And finally, I'll take some questions from the audience. So with that out of the way, let's begin um, to look at some of the significant developments since 24S. Um, so one of the highlights for me was that Justin Blake joined the core team in August, I believe. He's been doing a couple of things, fixing some bugs, but most recently, and I think the thing that is most visible to most people, is that he's been working on documentation and on polishing the book, especially lately. Um, so having someone other than me in the core team is something I appreciate a lot, and it's nice to have someone to talk to. And it's of course great to have someone who can focus on things that I have a lot of trouble motivating myself to do, like documentation, like the book. So really have to have Justin Blake on board uh, there. There were also some big improvements to code generation that landed in 0.45 of the compiler. Um, and so I think for some benchmarks, for some programs, I saw, like if you were computationally restrained, I, I saw some 300% performance increase um, due to the changes in that release, which is big. Gren programs run faster. It's always nice. Um, then Joey Bright, around the same time as this release, contributed the Web Crypto API. So if you're using Gren code, you have been able to encrypt and decrypt and sign things cryptographically through the Web Crypto API directly in Gren. No kernel code required, no interop required. Then May has done a huge effort on bringing editor support for Gren. So you can now use Gren in Neovim, Emacs, and Helix through Treesitter Gren, which May has forked originally from Treesitter Elm, but brought up to date for Gren syntax. And someone also picked up May's work and added support for the set editor. There are other editor supports available as well, but this is pretty big. I think and this only happened in the last 6 months. Up till now, people have been using Elm syntax highlighting to work on Gren, but now you actually have native Gren support in several editors, which is nice. Um, Probably the biggest thing for me was that I took a day off from work a couple of weeks ago and worked on Gren the entire day without any loss of income. So people have been sponsoring the Gren project on GitHub sponsors for a few years now, and finally it came up to an amount uh, so that I could spend a day working Gren without losing money on it, which to me was a huge milestone, and I hope to do more of that in the future. And of course, there have been many other smaller contributors. I think the Gren 24 winter release has been the most contributed to release of the project's life. There have been several minor bug fixes in the compiler. There have been several documentation changes and bug fixes in the core library as well. So I think this bodes well for the future of the language. I can really feel that more people are spending time on it now than just a year ago. So it seems to me that things are looking upwards. And of course, I had this video that was a long introduction to Gren, and it's been viewed over 19,000 times on YouTube. Again, another sign that interest in the language is picking up. Um, so all in all, I think, just these last 6 months have shown me that um, this is starting to become a thing, which is of course motivating to see, but it's also, I think, uh, you know, we're actually starting to go somewhere. And I think that's very enlightening. So that's some of the things that's happened outside development, right? But there's also happened a lot of stuff in development. So what is new in the 2024 winter release? And just to make it clear, the 2024 winter release includes a new compiler, and includes new core packages, right? Um, from the compiler point of view, there's some new syntax. So case off for pattern matching has been renamed to when is. This is a purely cosmetic change, uh, but it's made because I remember when I learned Haskell, when I learned Elm, case off was like the one syntax thing that made no sense. Well, in Haskell's case, there were many syntax things that made no sense to me, but in Elm particularly, case off I just didn't understand why those words were used. So this is a minor thing. It's purely a cosmetic thing. But I'm also aware that if you want to make a change like that, it has to be now before a ton of people use the language in really important, production critical things. Uh, so the change was made now. Uh, and had I thought about this a year from now, I might not have made the change because the project would be further along. I think this was my opportunity to fix that one thing that I remember I struggled with early on. More importantly is that custom types are now limited to 0 or 1 argument. So you can have a custom type of int, or you can have a custom type of record, or just a custom type that is a name, but you cannot have a custom type that carries int. That's no longer allowed in Gren. And the reasoning for that really aligns with the reasoning for removing tuples. And I just, in general, don't like I just in general don't like positional arguments. I think positional arguments is just it leads to brittle cryptic code, and I tend to always regret introducing positional arguments um, in bigger programs. So now you're not allowed to. You can, if you want to group things together, you can use a record, um, and that's really the only way. You have to name things if you want to have many of them. And this is one of those things, like I knew this is something that I wanted down the line. I thought about doing this when I extend what you can do with custom types, which will come later. But I also thought that this is going to be a change like this is going to be one of the most annoying things to fix uh, as far as breaking changes go. So the best way, the best point, the best time to break code is right now. So we're doing it now. Um, on the feature addition side of things, we now have web streams. So there has been a stream concept in Gren before, but it's been limited to the standard input streams. Now we have a full-blown abstract stream representation, and you can actually use this for a lot of things. And we'll get into that when we show the demo. But web streams really is the highlight of this release, and it's something that I think will be very interesting to see what people do with. Um, with the 24S release, we began the very first steps of rewriting the compiler from Haskell to Gren. That has now progressed a little bit with this release, so now the command line interface of the compiler has been rewritten in Gren itself, and which hopefully no one will notice, but It's, we have gone one step further on the rewrite path. Uh, it's made things a little bit more complicated because now the compiler consists of two parts. There's a Gren part and a Haskell part, and these two things communicate with each other through a JSON API. Um, so when you're building the compiler from scratch, it might be a little bit annoying, but for most people who are probably just going to install it through npm and use it from there, hopefully they won't really notice the difference. Which is to say, we've gone a little further in the rewrite. There's a new make static command, which allows you to create static executables. I'll show a demo of that later, and I'm actually quite excited about that as well. Now that the compiler rewrite has gotten further along, we also now you can now install the Grenlang package through npm, and you can actually use the Grenlang package through a JavaScript API if you're making if you need to invoke the compiler from JavaScript, you can do that. Previously, this was a separate package. Now this is just a part of the compiler package. Uh, so you can just invoke the compiler from JavaScript. No big deal. We also have a Gren package. This has already been released, so you can use that even before the 0.5 release or the 24-week release landed. But the parts of the Gren compiler that has been rewritten in Gren are now available as a Gren package. And of course, as the rewrite progresses, more stuff will be available in this package. The end goal is that you should be able to tap into any part of the compiler that you want uh, in a Gren program. The string module has now been rewritten, so um, it now most all functions, unless noted otherwise, work on code points instead of code units. Um, so a string is essentially an array of code units, but a code unit isn't necessarily a character. Sometimes you need two units to represent a single character, and this is known as a code point. Now all operations work on code points. And then there are three functions that allow you to uh, work on units, uh, three or four functions. But so for the most part, you will use on code points, but in performance critical code, you might rely on units if you know that whatever you're iterating over is either agnostic to code points, code units, or if you know that the characters you're operating on can be represented in a single unit. Uh, Previously, uh, actually in the previous release, we had reverted to only operate on units because in the release prior to that, it was kind of like a mix. Some functions worked on units, some functions worked on code points, and it wasn't clearly defined when uh, you were relying on units and when you were relying on code points. Now we always rely on code points unless otherwise noted, which should make things more correct overall. Um, and then the time traveling debugger is no longer available. It's actually been removed from the Gren project. There are a couple of reasons for this. I think the most important one is that I personally don't use it anymore. Uh, because in small projects, the projects are too small for it to be interesting. In big projects, the model is too big, too complicated, or the program is too performance sensitive for the overhead with the debugger to work. Um, so even in Elm code where this stuff comes from, I tend to disable the time traveling debugger because it gets in the way. Um, Another problem is that Gren, the time traveling debugger relies on runtime information, and that works fine now. But in the future, Gren might compile to WebAssembly, and then it becomes a challenge. Say so by getting rid of it now, we get rid of that potential stumbling block later. And finally, there are a couple of minor changes to the API in the core package. So there have been some name changes, and of course the string module has been rewritten. So the most important ones, I think, is that filter has been renamed to keep if. filter map has been renamed to map and keep just, uh, and I think flat map is now map and flatten. And this is an attempt to make code easier to understand for those who aren't necessarily acquainted with functional programming. Um, and there are a couple of other changes as well. So if on the top of my head, uh, retrieving the size of a dictionary is now called count instead of length. There are still some functions called length, but those are functions that return the response in O1 time. Whereas count, hopefully it becomes more obvious that this is actually a linear operation. And there are probably a couple of other minor things that I've forgotten, but there are some changes to the core package here and there. All right, so that is what is new. Um, and before I show anything else on the demo, I'm just going to make sure that people are actually people are actually viewing this. Otherwise, I mean, just people are actually. All right, great. People, it seems that people are actually viewing this. So just sanity check before going on with the demo. Um, but yeah, let's see a demo. So that was the wrong screen. Guys, let's see if I can change that real quick. There we go. So I hope people can read this. There we go. Justin's in the commentary. I thought you wouldn't be able to make it, Justin, but it's nice to see you all the same. Uh, can people read my screen right now? I'm just going to assume that you can. And then I'll pay some close attention to the chat in case you can't. This is the cat program. It's a very simple, like it's a, this is the cat example program where we implement the cat program in Gren. I wonder if I can say cat one more time, but this is really simple. Let's see if I have, um, double check that I have the correct version. It's the 05 version, a little bit small. Let's see if I can, right, let's do that. Then I hope that's big enough. So right, so we're just so we got the new version of the compiler. We are going to compile the cat program uh, to app. That's probably fine, and then we can execute the cat program, uh, pass it the Gren JSON as an argument, and lo and behold, here is the contents of Gren JSON. Now, this is normal. This is the normal way to compile a program. In Gren 24W, there is a new command that you can use, and it's called make static. We're going to call this app static. And you'll see it will spit out more things. What it does now is that it compiles your application using slash dash dash optimize. And then it executes that application all the way up to the main function. It doesn't call the main function, but it runs everything else. Now, in the pure program that you write to Gren, that essentially means that nothing happens, right? So why are we doing that? Well, when we execute a program, but don't call the main function, what ends up happening is that all the functions are being parsed, right? All the code will be parsed. All the constants will be evaluated. And then right before we shut down the node runtime, we store a snapshot of the state of the world just before you call the main function. And then we take that snapshot and then we inject it into a copy of the node binary that you're using to run the compiler. And so you will see that I have um, two applications. The app that I wrote compiled normally, which is 136K in size. Then we have this app static thing, which is 50 megabytes in size. Now, most of these 50 megabytes are Node.js. It's a simple, it's pure, it's just Node.js, right? A static build of Node.js. And then it also has this 136K JavaScript bundle injected into it, but already partially initialized. And when we run this, you can see that the output is the same. There's no difference between them, but one is a native executable and the other is a JavaScript file. And then you might wonder, what is, and I use Hyperfine all the time, but I just forgot the syntax for it. um, right. So if I run Hyperfine, we're going to execute the program 10 times, and we're going to run JSON and app static run JSON. Hopefully this is correct. Yep. And here you can see that uh, app static run JSON executed 17% faster. Um, and that's not because, now of course this is probably a bad benchmark because most of these stuff, most of these things will be cached, right? But we're saving 10 milliseconds here, and most of that is in startup, because we're still using Node, right? So we're not getting better performance, but we are getting better startup time, because the Node.js compiler in the case of app static won't have to parse the code. It won't have to initialize the constants. It can just start running immediately. Now, the flip side to this, of course, is that this Node.js file can only run on Mac OS, the same version of Mac OS that I'm running, the same CPU architecture that I'm running, right? So you have to compile a static build for every platform that you intend to run it on. And in return, you get something that boots up fast, that starts faster, right? And I also believe this is self-contained. So if you were to copy this into a Docker image, then you can have a very slim Docker image. Uh, yeah, and of course, as the size, as your program gets bigger, you will see even more gains. Like cat, obviously, it's a very small program, so there aren't really a lot of things to save here. But I did previously test uh, creating a make static version of the compiler, and at that point, we saved nearly 70 milliseconds uh, just by going through the make static route. So make static, I think, is something that's really cool if you have a pure Gren program that should work as a command line interface, and you want it to run as fast as you can from the command line. This is a nice option to have. Now, there's one big caveat to this, and that is that it only works for pure Gren programs. So if you're interoperating with JavaScript, it's not going to work. You can obviously like it uses Node.js API, so you can reverse engineer this stuff. The Gren code obviously is compatible with this, but this Node.js feature doesn't support, it has several limitations. Now, Gren fits those limitations just fine, so any Gren program will be able to compile in this way, but an arbitrary JavaScript file will not. So make static only works if you have a pure Gren program, and not when you're doing interrupt with JavaScript. But other than that, it's a nice feature to have. Right, right, right. So let's move on to a second example, uh, which is streams. Um, which is one of the big features in this release. So this is an integration test, and so the code here might not make a lot of sense, but it does show you uh, this new API, which is, streams. Let's actually look first, see if I can find the documentation for it, and we'll discuss it a little bit um, while it's running. So here is the documentation for the new uh, Gren core, and it has a new module called Stream. Now, for those who haven't written a lot of Gren, the Grenline core package is the package that is available to any Gren program, even if you're running uh, it's available on browser applications. It's available on JS applications as well. The cool thing about streams, well, okay, let's start there. So we've had streams before in the node package. So if you were wanting to use streams, you had to use node package, and to make matters worse, uh, it only worked for standard input. Streams in Gren 24W has been completely rewritten, and it's now a common API, so you can use it in any application that you are using, and you can do a lot more with it. Now, the underlying representation of streams is web streams. This is a web standard. It's available in most browsers, and piggybacking on that gives us a bunch of benefits. One of those benefits is uh, more theoretical at this point, but that is that stream is a primitive in JavaScript and it's supported by web workers. So in the future, when we want to support parallelism in Gren itself, streams can be used natively with that. So by exposing that to the system, we are kind of like we're sort of setting ourselves up for future concurrency work, which has been an important thing. Another thing that's very important with the built-in streams is that we get access to a bunch of native transformation streams. I'm going to go over what transformation streams are in a bit, but we get access to them from Gren. One of them is streams that converts things from strings to bytes and bytes to strings, but also transformation streams that takes bytes and compresses them using gzip or deflate. And of course, decompressing is also available. So that just is given to us for free by uh, by using web streams as our underlying representation. And again, this will be available both in Node.js applications, but also in browser applications written in Gren. Right? So that's quite nice. Now, as to what streams are, they are meant to be used when you are reading large parts of data that you don't necessarily want to be represent fully in memory. So if you're reading a file on 1 gigabyte, uh, on 1 gigabyte, and all you're really doing with that file is to hash it to check if it's the same as a previous version or whatever, you don't actually need to store the entire thing in memory at once, but you can do the hashing as the bytes are being read from disk and then just forget about it, right? And that's where streams come in. That's where they are very, very handy. Um, but they can also be used as a communication primitive, right? Um, so if I have a stream and you have a stream, you can send me messages over that stream. So it's also useful for those sorts of operations. Now, web streams in particular has three notable concepts. You have the concept of a readable streams, which you can get values out of. Then you have the concept of a writable stream, which you can put values into. And then you have transformation streams, which work between these two. So you can write something to a writable stream, that value can go through one or more transformation streams and end up as something else on the readable end. One interesting thing that you have available in your arsenal is an identity transformation stream. And a transformation stream really is just a pair of a readable and writable stream, and whatever you write on the writable end goes through a transformation and ends up on the readable stream. Now, the identity transformation stream doesn't transform the data at all. So whatever you write to the writable end will end up on the readable end. And you can use this and you can create an identity transformation, and then you can break it apart and use it as a communication tool, right? So I can create an identity transformation. I can keep the writable end of it, and then I can pass the readable end onto somewhere else. And now I can communicate with wherever the stream ends up. Streams in Gren respect, or they handle back pressure. So when you create a stream through a transformation stream, you can define a capacity for the readable end and the writable end. And if you're trying to write, or when you're writing something to a writable stream, it will first check if we have gone over capacity. And if we have, we will simply wait until enough messages has been passed through the stream so that we're under capacity before writing again. And the same thing happens on the readable end is that if there are no values in the stream, we will wait until something becomes available. And of course, if there are tons of values available, then we will just return immediately. Um, so streams in Gren, they respect capacity, and as such, you get this um, back pressure system where, for instance, if you're reading a file from disk, uh, you won't just, the file won't just hand you chunks faster than you can process them. It will actually, like, you will get a chunk and then you'll process it and then tell the system, give me one more, and then it will only read as fast as you can handle it, essentially. You also have the option of creating your completely custom transformation action. And this sort of works like a miniature Elm architecture application just at the level of a stream. And so you can get things from the writable end, and then you can choose to pass it on to the readable side, or you can say that, I don't have enough data to pass it on to the readable end just yet. So I'm going to wait until the next chunk comes along. Or you can say that, I've gotten an invalid value, so I'm terminating everything now. You really get a lot of, you can really create whatever you want in the case of streams here. So you can use this to have a stream that only returns full lines to the readable end, for instance. Uh, Now, there are some challenges too by relying or essentially being written on top of a web streams. Like the web streams have been designed for use in JavaScript. Not all of the design constraints they're subject to really applies to Gren. Uh, and some of these things are a little bit painful to work around. So I'm going to mention a couple things that are annoying, but it's essentially the fact of life. If we're going to expose primitives of the platform, we're going to have to adhere by the rules of the platform as well. Now, one particularly annoying thing about web streams is that when you're reading from stream, you have to acquire a lock on it. And what that means is that until you're done, no one else can read from the stream. And if someone else were to attempt to read from the stream, you will get a error saying that this stream was locked. And so there can only be one reader at once, there can only be one writer at once. And if you get a locked error, you have to decide, are you going to try this again until it works, or are you just going to give up? And you have to actually you have to make these choices. Now, in a lot of cases where you use streams, it's okay to deal with this. Like, this is a reasonable thing to deal with when working with streams. But for instance, with standard IO, the standard input and output streams, This can be quite annoying. So uh, the standard IO streams, like standard out, standard in, standard whatever, standard error, are currently implemented as web streams, which means that every time you want to write something to the terminal, you have to deal with error handling because the stream might have been locked, uh, right? If you have two uh, producers writing to standard out, they can block each other, and you have to handle that somehow. And then, of course, they can be closed either because there are no more data left, or they can be canceled, meaning they've been terminated for some erroneous reason. Which leads me to the other thing that's quite annoying, and that, or not quite annoying, but it's a fact of the API. It's just a restriction on the API we've been given, and that is that streams in web streams errors are strings. Um, and it makes sense when you think about it in broad terms. Like so when you are writing in Node.js applications and you get input stream, the standard input stream could be a terminal where a user writes things to you on a keyboard, but it can also be a file, and it can be a socket to some remote service. You don't actually know what it is, and so you can't actually type the error because you have no idea what sort of error can happen. And in fact, the stream could just be a custom stream that no one has, that's been created in the user. So you have no idea what the stream is going to be. And if you've piped several streams together, meaning that whatever is written to one stream is passed directly onto the other, if one of those fails, you don't know what stream that was. So you also don't know what the error was. So it makes sense, but it's also a bit different from what we're used to in Gren. That all strings just all streams can fail with a string error. Other than that, though, I think it's. I think this gives us a lot of things that we haven't been able to use before, uh, in a reasonable package. I think. Now, one thing is um, one thing is being able to create your own streams, your own through a transformation stream, for instance. But there are some APIs that actually give you a stream as well. So the file system module now has a create write readable stream and a create writable stream. So you can actually stream data from the file system through a transformation frame like gzipping or decompressing or whatever, and then writing it back out or passing to some other place. So that's available. And if you're using the child process API, you actually have the option of getting streams as well. And you can communicate, you can get streams from the new service that you can communicate with um, through streams. And I think, and of course, the standard input output streams are also web streams now. And hopefully we can add support for more streams in the future, as in streams from the HTTP client API or streams from HTTP server, maybe even TCP sockets when that becomes available. Um, but you can also already do a lot of things with streams. And I'm going to show you a very quick example here on how you would use it. So if you want to write something to stand it out, you would do it like this. Um, there's a helper function called write line as bytes because standard out is defined as a byte stream. And so we have a helper function that takes a string, converts it to bytes, and passes it on along to the string. Here's an example of printing something to standard out, reading something from standard in, and then writing a response back out again. You can also take an array and convert that to a stream. You can create custom streams that way. And here's an example of compressing something where we create a writable stream. Essentially we're creating a new file called compressed.txt. We check if there's an error. We do some error handling, and then we essentially ask for data from standard in. Once we have data, we convert it to a stream, and then we pass it through a gzip compression stream and pipe it into the compressed text file. And once that is all done, we're right done, and that's it. So in these few lines, we take data and we compress it, and then we write it to this file system, to this file system file. And of course, decompression is just the same thing in reverse. It's quite simple, and of course, since it's using streams, it's also quite efficient. Anyway, so there is a new repo. It's called integration tests. Uh, you can find it on GitHub, of course. Um, and this gives you, and this allows you to view all these things for yourself if you want to look closer at it. All right, I think that was it for the. I'm just going to double check, but I think that was it for the demo. Uh, right, there is a Gren package, but again, this is available already. But you now have the Gren compiler node package. And here you have access to the parts of the compiler that has been written in Gren. So the Gren compiler, the Gren part of the Gren compiler, actually uses this library directly. This is the same code that is in the compiler. And so when you see the package definition, this is how you represent packages in the compiler itself. Same thing with semantic versions. And of course, the pretty printer is what we use to print things to the terminal. And the CLI parser is how we actually parse the command line interface. And so if you want to write an application that looks and feels like the Gren compiler, you have all the building blocks right here. And you can use the Gren compiler itself as a demo or as a sample code to show you how that works. And finally, you have this compiler blob module, which allows you to download the Haskell part of the Gren compiler and invoke commands against it. Now, currently, invoking a command um, returns command. A bit too many commands for my taste. Hopefully, we can change this into task in the future so that you can invoke the compiler and do something with the result. Um, but yeah, you have access to the same things that the compiler itself had access to. And again, with each new release, this thing will just get bigger and bigger, and it will give you more and more functionality. Uh, so if you want to do like in the future, you will have access to the parser, you'll have access to the AST, you'll have access to the formatter, which means you can spec up some AST, pass it to the formatter, and now you have code generation. That's the goal, right? So hopefully that will make it easier to analyze code, to generate code, uh, and to make tooling. Right. So that was the demo. So what is the plan moving forward? The plan moving forward really is to, first of all, add support for more types of streams. So you can have streams uh, from the file system. You can have streams from standard I/O. You can have streams from child processes, but you can't have streams from the HTTP client. And you can't have streams in the HTTP server, and we want to enable that. We want to give you that so that you can have efficient communication over HTTP. Um, but the big feature of Gren 25S is a new centralized package manager written in Gren. It will still be part of the compiler, right? So this is part of the Gren rewrite. We're rewriting the package management deal of it, and it's going to communicate with a centralized Gren package server. And the reason we're doing that is so that we don't have to rely on Git. Now, Git has served us well, but we don't want to be tied to a specific version control system, even if it is the most popular version control system. We want to support any project, no matter what version control you use. And of course, we want to move away from GitHub. We don't want to be reliant on that. We could have solved this without going through the centralized package manager route, but I think having an actual package manager makes this a lot nicer. And as a benefit, it allows us to dog food the Gren language uh, to to find more flaws and find more bugs. Um, so I think it will be a good test for language to actually write an important service, HTTP service, in the language itself. Um, and another thing about this, of course, when we do this, everything that deals with package management in the Gren compiler will become available in the compiler node package. Um, and most of the command line, uh, if we just look at the number of commands, most of them deal with package management. So by doing this, most of the things you can invoke through the compiler are now actually written in Gren itself, which should reduce the size of the Haskell binary and um, uh, make those parts of the compiler run a bit faster because you don't have to involve a second program. And finally, if there is time after rewriting the entire package manager step, then the goal is to rewrite the Grenlang parser package, because that is the critical part of rewriting the parser of the compiler, which is the goal for 25W. Now, of course, these are just the plans that I have for 25S. There are other people contributing, as I mentioned in the recent developments slide at the very beginning. And if you want to be a contributor yourself, there are a number of ways of doing that, and I welcome you heartily. But of course, the first step is just to use Gren, and if you find any bugs, report them. If there are things you think could be better, let me know. I would love to hear about it. And of course, if you help us spread the word about Gren or create packages to enable new functionality, in fact, if you're bold enough, you can reach out and ask to implement a new language feature or a new API, right? As mentioned earlier, Joey Bright enabled the Web Crypto API as a central API, and I think that was the first major thing he did, which I feel a little bit bad about because that was a big ask of someone to kernel development. But if you're motivated to do those types of things, you will get the possibility to do so. So do reach out if you think you could deliver something of great value to the project, no matter how big, no matter how small. And of course, if you can't do any of these things, but you would still love to see the project move forward, then do consider becoming a sponsor of the Grenline organization of GitHub sponsors. As I mentioned earlier, I save up that money, and when it's big enough, I take a day off from work and spend that day hacking on Gren itself, which it really, and the more I can do that, the faster the language will be completed, right? So that's also a very good way of contributing. And that's really all I had planned to say. So I'm going to stick around a bit and see if any questions pop up, and I'll answer um, whatever questions you have. No questions as of yet. I can see Justin is excited about invoking compile directly. I am as well. Although mostly I'm interested in seeing what people do with it. Um, MC Post Leipzig. No questions for me, but thank you very much for the tour. You are welcome. Also, I think I mentioned it, but I might, no harm in doing it again. Gren 24W is available. It's just not been publicly announced. So if you want to do, you can simply do npm install Grenlang, and it will give you the latest version. Um, the package server hasn't been updated with packages yet, but I intend to do that just after the stream is closed. So so yeah, there's you can check it out if you want to. Will the language be stable for a while? Yes, it will. So the goal for the next release is to rewrite the package manager, but I don't intend to change syntax or change any of the core APIs. I'm trying to save that for when the parser is being rewritten, which at the earliest will happen a year from now, or at the earliest it will be available a year from now. On the other hand, when the parser is being rewritten, I will probably introduce as many breaking changes as I can. So this is one of the quiet before the storm moments. Um, but yeah, the code that's being written starting with this release should be you shouldn't have to change it for at least a year. All right, I think that's it then. Uh, Thank you all for watching, and yeah, happy hacking.